All right, let's go ahead and get started. So again, hello everybody and welcome to today's webinar presentation, Designing Snowflake for Scalable Data Applications, brought to you by Snowflake. So I would like to pass it off to our presenter, Kevin McGinley.
My name is Kevin McGinley, and I'm a technical director in the product team at Snowflake. And I'm here today to talk to you about designing Snowflake for scalable data applications. So, for those of you who may not be familiar with the data cloud, Snowflake built a global network for all of its customers to do amazing things with data at near unlimited scale, concurrency, and performance. And of course, Snowflake is the platform that powers the data cloud, but it's not just about access to a platform. Imagine if you logged into a streaming service and there were no videos there to watch. That would not be a very impressive experience from a consumer perspective. And so the data cloud is all about how Snowflake customers can have access to data immediately on the platform by point-to-point sharing or acquiring data through the Snowflake marketplace. And that global network allows customers to do amazing things with data across a variety of different workloads. So let's talk about a few of those. Obviously, you're probably familiar with Snowflake as a cloud data warehouse. That was how we were founded, and that's the primary workload that we were initially brought into many organizations for. And of course, today we're going to talk about building data applications, and I'll cover those a little bit more later. And data sharing is obviously a key component of what I mentioned that powers the data cloud. The ability to do point-to-point data sharing or providing data on our data marketplace or acquiring data from our marketplace without actually having to copy the data between Snowflake accounts is a really powerful enabler for organizations to do all kinds of new inventive things with data. But it's not just those workloads alone. Our customers have found over time that they can do all kinds of other workloads as well, like data engineering. Once the data lands in Snowflake, they can run powerful transformations over the data to enrich it to be better consumable by its customers and end users. They can take a data lake design approach to structure the data and the zones within Snowflake in a way that allows them to manage incredible volumes of data across many different data domains of all sort of shapes and sizes, and manage that with strong governance and have incredible performance when it's time for users to query that data. And that enables more advanced things like data science. Instead of just doing descriptive analytics or basic reporting, you can enable more powerful machine learning algorithms on data that's in Snowflake, whether that's to do feature engineering to figure out which parameters are best used in a model, to do scoring and training, or even to do real-time use of machine learning models in Snowflake. So these are the many workloads that our customers use. But today we're really here to talk about data applications. So what do we mean by data applications? Well, many of us kind of understand the term application, and that probably in our mind sort of conjures the image of a human sitting at a computer entering in transactions. And the scale of those, were maybe powering a small function within the business, or maybe it was an ERP application that would run sort of the back end of a business. But data applications is sort of a new breed of applications that involve a significant amount of complex and fast changing data. And customers are looking to deliver out to their partners, suppliers, or their own customers to build new revenue streams and data exchange opportunities to power things like next generation CRMs that don't just have data from one location like Salesforce, but have data coming from all kinds of different places, and provide a true 360-degree view of the customer. It could be a payments application that requires a vast amount of credit card transactions, not just across one merchant, but many, to do spend history and detailed reporting on the payments that are in that application. Or maybe it's a security analytics application that has lots of log data coming from networks and servers and operating systems and applications to understand when there might be a threat and sort of detect those threats and respond to them. So this is a whole new realm of applications that have been enabled by platforms like Snowflake. And what it really boils down to is that all of this vast amount of data is coming into a platform like Snowflake. It could be events, logs, social media posts, lots of detailed transactions, sensors, etc. And then there's usually some sort of application UI that serves as the interface to customers, partners, suppliers, et cetera. And that application UI could be an embedded commercial application. It could be an application UI that the data application owner built themselves. It could be an API. There are all kinds of different interfaces that can go out to these customers and partners. But the real trick here is that these apps are multi-tenant applications. And that's what we're here to talk about today, and how this is different than building out just sort of an internal application for your end users. You now have to build something at scale for your customers, partners, suppliers, et cetera. So what are the challenges that go into that? Well, the first thing is that you first have to think about how you're going to organize and secure the data. That is definitely an important step in starting your design of your application. And there are a number of different ways that you can do that we'll talk about. From there, it's about how can you scale to a large number of customers. You may be starting off small, but you may have grand plans to scale to tens, hundreds, thousands, tens of thousands, millions of customers. How are you going to do that? And how are you going to adopt a design that you know will be able to scale to whatever scale needs that you have? And then your application is probably not a one-trick pony. It's not a one-stop shop. There's going to be multiple workloads that are running from back end and front end, and you don't want those colliding with each other. And you want to be able to run them continuously around the clock, not just in discrete time periods. How can you do that in a multi-tenant application? And all of that you want to do with as little overhead as possible, because you want your team to focus on building the application, not managing things under the covers, infrastructure, building in disaster recovery, high availability, et cetera. You want that to all be out of the box. So a lot of this is enabled with the Snowflake architecture, and I'm not going to dwell on this too much, but the key thing here is that the data cloud is delivered across the three major cloud providers, because we have built a cloud agnostic layer that allows us to use the underlying storage, compute, networking, security of those cloud providers to build a fully functional, relational, ACID compliant, transaction based database that can handle all kinds of data of all kinds of style, shapes, and sizes by separating storage from compute, so that we can bring multiple workloads to the data without actually having to load the data into the compute like some other platforms. And we have a cloud services layer that handles things like, how do I turn object store, which is immutable storage, into a fully transactional relational database that can handle create, insert, update, delete opportunities and statements. We want those to all operate without having locking and dirty reads and things like that. How can we manage compute so that it's load balanced, it's running when it needs to be running and not running when it doesn't need to be running? All of those are built into our cloud services layer and make Snowflake a great platform to build data applications on top of. So let's dive into what the sort of common tenancy approaches are for data application customers. There are going to be hybrids to these, and there are going to be little offshoots, but most fall into three typical design patterns for building data applications. So the first is what I'll refer to as multi-tenant table. Now, this doesn't necessarily just relate to the data, but the idea here is that we're going to combine customer assets or tenant assets onto common objects. So that could be common tables. We're going to load their data into common tables, or we're going to use common virtual warehouses or common compute to power their queries. The second option is an object per tenant. Maybe we're going to create a table per tenant or a schema or a database, or maybe we'll give each tenant their own compute. This is what we refer to as object per tenant. But we have another level of isolation called account per tenant. This is where we actually split customers into their own Snowflake account, which you can think of as like a database instance. This provides the greatest degree of isolation that Snowflake can offer for all of the different tenants to be in their own account. And we'll dive into the sort of details of what makes that up. But the important thing to understand here is that you're going to make your decisions based on a combination of storage, security requirements, compute requirements, and connectivity requirements. And you might end up designing a hybrid of these when you think about things like storage might be done one way, but compute is done another. And we'll talk about what some of those hybrid opportunities are and why you might want to make some of those choices. So let's talk a little bit about some of the traits of each approach so that you get a feel for them before we dive into them in more detail, as well as what some of the Snowflake features are that enable some of these capabilities. So with the multi-tenant table approach, or MTT, the data for each tenant is generally the same. You might have some flex fields that different tenants use for different purposes, but generally speaking, they're the same data model, whether that's one table or a collection of tables. The sort of general premise behind MTT is that they're going to have the same data model, and that within that data model, you're going to be able to identify all of the rows for a given tenant with some form of a tenant ID. Whether you call it tenant ID or not is irrelevant, but you'll be able to understand which rows belong to which tenants. Generally speaking, you could give each tenant their own compute, but it's also possible to pull them on common scalable compute as well, and we'll talk about that. And for this model, here's where you can be the most scalable. Typically in the tens to hundreds to thousands of tenants and beyond. We have some customers that are in the hundreds of thousands and millions of tenants within their multi-tenant table approach. And this is what we generally say is the most scalable model. However, in OPT, you might have a situation for your data application where each tenant is getting a different data model. And then this approach is going to be more appropriate for you. You might also not be comfortable with managing entitlement tables and handling the row level security requirements that are required in an MTT setup. And so OPT might be better for you because of that. But you're still going to be comfortable with RBAC because that's how you're going to sort of delineate between the different tenants, whether it's different databases, schemas, or tenants that are tables that each tenant can access and use. You might give your customers their own dedicated compute, so their own virtual warehouse or compute per tenant. And the scale of this is typically in the tens to hundreds of tenants, although you can go into the thousands. There's just different considerations that you have to think about when you're going to go that high and operate that many databases or that many schemas within your Snowflake account. Account per tenant typically involves the greatest degree of security. You need to isolate tenants for regulatory, contractual reasons. You might have to give them their own encryption keys, or there might have to be very specific IP firewall rules that you have to enable. And you may not be comfortable with RBAC as a means to sort of separate tenants from each other. You need a harder line to do that delineation, and Account provides that. You might also need to provide connectivity directly to the Snowflake account instead of coming through an application UI, and we'll talk about that. Maybe they're bringing their own tool. Maybe you want to use the Snowflake UI. The bottom line is they're now aware that Snowflake is there behind the scenes versus it being obscured behind an application UI. The scale for this is also typically in the tens to hundreds of tenants. Again, you can go higher than that, but this is where we typically see the sweet spot. And there are definitely considerations that you have to keep in mind if you're going to go into those higher ranges. So let's talk a little bit about this from a storage perspective, and then we'll talk about it from a compute perspective, because there definitely are different considerations and different Snowflake features that you want to be aware of from a storage versus a compute perspective. And again, you might make different decisions for one versus the other as it relates to tenancy. So let's go back to our design patterns and let's focus on storage and change up the visuals a little bit here to be a bit more descriptive. So in multi-tenant table, you're most likely going to have source data coming in. It could be from one source, it could be from many. I decided not to draw many on this in this diagram here. We'll get to many on the next couple diagrams. But ultimately, that source data is going to be enriched and put into a serving layer that operates as that multi-tenant table. Again, it could be one table, it could be several tables, but the idea here is that there's going to be some layer of entitlements where we can identify which rows belong to which tenant. So if you kind of follow the color visuals here, if we have the orange tenant logging into the application tier, we're going to get to the orange box inside that multi-tenant table there. The purple is going to go to the purple box, the pink's going to go to the pink box, etc. We'll have mechanisms based on how they're logging into that application tier to be able to route them to the right slice of data within the multi-tenant table. Object per tenant basically means that we're going to separate each tenant data into its own object. It could be their own table for a single reporting table, if you will. It could be you're going to separate them by schema within one database, or it could be that you're going to create a database per tenant. Either way, you could have source system coming in where it's one source per tenant, as in the pink example there, where the source data goes directly into the corresponding tenant database. Or you could be fanning out your source data. If the source data is coming in for all tenants, but you want to have an object per tenant model, you can fan out the source data into each corresponding tenant's database schema or table. And then from the application tier, it's a matter of routing the orange tenant there to the orange database, the purple tenant to the purple database, the pink tenant to the pink database. And I'll talk to you about how we do that as we get a little bit further into the presentation here. And then lastly, we have account per tenant. And the only difference here is that we're going to put that account boundary around those different database objects. And more than likely, we're using databases here, not schemas, to differentiate tenants because each tenant is going to be in their own account. And again, it doesn't matter whether you've got sort of one source data coming in per tenant or you've got a single source that fans out into multiple. And there are multiple ways to get the data from your source to those individual accounts, either through ETL or through data sharing. And we can talk about the differences behind those. But the one key point here is that in some of the account per tenant use cases, the pink tenant shows that it's going directly into the Snowflake account instead of going through an application tier. And we'll talk more about that in a bit. So let's talk about some features then that enable the sort of storage decisions that you might make and how these apply to you building a scalable data application. And the first one that I want to talk about is Snowflake's support for semi-structured data. So Snowflake can ingest regular structured data, in a delimited fashion and put that into a table just like any other database. And in that scenario, you've got a fixed number of delimited columns coming in from your data source, going into a table with the same number of columns. And that is sort of typical in the relational database world. But you might have semi-structured data. Maybe the data is in a JSON format, or you may decide, hey, you know what, my data changes a fair amount. The number of columns, the number of attributes can change. I don't want to be locked into a fixed schema when I ingest this data. So Snowflake has a variant data type where you can write the entire document as is, and we'll collect metadata and columnarize it behind the scenes so that you never have an issue where, oh, new attributes appeared and that breaks the ingestion pipeline. And that's the benefit to you from a scalable data application perspective. You can ingest data in a schemaless manner for easier maintenance. And you don't have to worry about parsing out those attributes because we're doing that for you and giving you a SQL notation that you can use to query it. And that allows you to then apply schema on read. Now, you're going to want to think about performance, though, because applying schema on read may be something that you need to do in intermediate materialization so you can get faster performance. But that's something that you can think about from a pipeline perspective. You also may want to think about table clustering if you're going to do the multi-tenant table approach. Now, we're going to talk about two different types of clustering in this presentation. This is clustering as it relates to how we organize the data in files that we call micropartitions under the covers in Snowflake. You operate on a table, but behind the scenes, Snowflake is storing it in many different files that you don't need to worry about. However, in a multi-tenant setup, we want to make sure that we organize all of our tenants into as few files as possible. so that when we query for a given tenant, and most of your queries in a multi-tenant application are going to come in by tenant, we want to scan as few micro-partitions as possible for better performance. So you can see on the left side, if we're looking for tenant 2, we have to scan 2 micro-partitions. But in auto clustering on the right-hand side, we actually only have to scan 1, and that can make your performance improve for some of the queries that you want to serve within your application. Now, obviously, you need to think about the time and cost that it takes to do this auto clustering step. Snowflake will automatically manage it for you behind the scenes with just a simple table definition, but it does take time for this to happen, and there is a cost associated to it. So you'll want to think about that as you design your application and design your pipelines. Materialized views can also be a great way to accelerate performance within your application. One of the common things that I see in many data application customers is they're usually aggregating the data or reducing the data down to just what's core for the data application serving needs. And in other database platforms, materialized views are sort of a manual process and they lock when they're refreshing. In Snowflake, they're automated and always guaranteed to be available. So we will give consistent results even while the materialized view is refreshing. This helps to simplify your pipelines, and it allows you to do things like turn that JSON into a much more performance structured data set. It also allows you to do things like apply a unique table clustering scheme for different access patterns, maybe tenant and date or tenant and product in your table clustering scheme. Or this could be the way that you create your object per tenant in a fan out scenario. All of those are the benefit to you in building out your scalable data applications. Now, some things that you might want to think about when you're using materialized views is the limits on query definitions. Because of our automated refresh of materialized views, we have a limit on what types of statements you can run within them. So you'll want to be aware of those and understand the limits there. And you also want to look at your data. How much is your data changing? High churn data is maybe not a good fit for Snowflake's automated materialized view service. You may want to aggregate that data through another mechanism instead. And I talked about it before, but it's worth dwelling into a little bit more. Data sharing is something that our data application customers, when they realize how they can take advantage of this, it really opens up the door for how they can design their data application. So let's review what the feature is all about here first. So first, I'm an application owner, and I am going to be able to allocate or designate a series of database objects as a share that I can share out to my application tenants who also have a Snowflake account. And that creates basically a read-only database within their Snowflake account without actually copying the data into it. And this means that they have ready to use live secure data that they can query. And as you're updating the data, they can get those live results. So this is a fantastic thing to think about in scalable data applications when you don't want to necessarily enable all kinds of different workloads and use cases that would require you to do a lot of engineering and a lot of build within your application. You can focus on a few set of core features and then share the data out, the raw data out to your application tenants for them to take on other workloads themselves. This also means that they're paying for those workloads because in a data sharing scenario, the consumer is actually paying for the compute to query the data. So you can offload some of those costs to your customers by giving them more flexibility with what they can do with the data. This also means that you can enable better bulk data access scenarios. So rather than having users log in and do massive data exports from your application or connect their own BI tool and download to Excel through a BI tool, or have an API that's trying to serve back hundreds of millions or billions or tens of billions of records, you could enable data sharing instead, and then you don't have to worry about maintaining this extra layer of your application to handle these more complex scenarios. Now, the one thing that you will want to think about is that data sharing is based on a cloud and region pair. So if you are going to share out to your customers in multiple clouds and regions, you do need to understand the Snowflake replication feature so that you can better understand how to architect your application for data sharing scenarios. So let's talk about security considerations for storage then. So what are the things that you need to think about as it relates to the access? So the first thing that you want to think about is secure views. This is how you can enable row level security for your MTT objects using an entitlements table. So what basically the way this works is you have a table which designates the tenant ID and what associated tenant can see that data. And in your application table, as I mentioned before, you have that very clear tenant ID delineation for each row. And what that means is what you can do is then your tenants that are coming in um, based on some identifier, either through database user or through database role, we can say this tenant is supposed to see this slice of the data. As you can see there in ABC, while tenant XYZ is supposed to see a different slice of the data. This means that you don't have to build in complex SQL injection into your application to inject predicates into all of your queries to make sure they're filtered by a particular tenant whenever they're going back to Snowflake. But it does mean that you need to think about a process to manage your entitlements table so that it's not accidentally updated by a developer in the wrong way. Your entitlements table should always be managed by an automated process that is based on things happening within some upstream source system where you define your entitlements, not based on some developer having to go and insert or update records in the table manually. And ultimately make sure that you're thinking about your connections to Snowflake from a user or role perspective, because that's what's going to drive how the tenant sees the right slice of the application. Okay, so if we move on, we also have a dynamic data masking capability where you can have column level security with policies. So if you're dealing in an application that has PII or PHI data, and you don't want your developers to see some of the fields within the customer's data, you can create policies that will mask those columns to your developers such that they don't see the entire field or they only see a partial amount of the field, as you can see there in the examples around phone and email. And that will allow your developers to work on the data, do all the development that they need for the application without you worrying about exposing customer data to your developers, but then allow the tenants to see their own data and see the outputs that they're supposed to be allowed to see as it relates to that PHI or PII data. Now, you want to make sure that you keep the number of policies that you have in check. It's really easy to have policy explosion. So try to design policies that can be as broadly applied as possible. So moving on, so we also have row level policies as well. These are coming soon and they work much the same way that column policies do. The row level policies allow you to define a row level filter for different roles within your application. And this would be another way that you could enable tenants to see only their slice of the application. Now, the benefit of this when we enable this in Snowflake is that you'll be able to push the definition of that row level security up to a higher level DBA function within your application more easily, because policies are more highly governed than views are. So for those of you that looked at the secure view functionality and thought, I need a little bit more stricter governance over the row level security, policies may be the answer for you here, because you'll be able to define those policies at a higher level within your administration, and then you can centralize that and make it a bit more resistant to human error. Obviously, you still want to keep the number of policies in check here, design policies that can be broadly applied, just like what we talked about with column level security. And then, of course, you need to think about RBAC, or role-based access control. And the idea behind this is that you're going to create roles that have privileges on certain objects within your Snowflake account. And those objects can be both compute and they can be data-centric. And you'll use those privileges like viewing and modifying and querying, selecting and inserting. All those privileges will get us into privilege-based roles on the objects themselves. And then you'll have functional roles within your application. I've got some very simple ones there, a tenant role, a developer role, and an admin role. You could have more complexity, of course, but you're going to create a hierarchy then of those object-based privileges and grant those to your more functional roles. And then you're going to grant those functional roles to the different users that are going to be accessing Snowflake. So creating that role hierarchy will make it much easier for you to sort of manage what permissions a given role has. So you're not having to constantly update lots of different roles. And then you can sort of grant those to whichever user approach that you want to do within Snowflake more centrally and easily. Just keep in mind that account per tenant still requires some RBAC due to administrative roles in there. So you're not completely getting out of needing to design some kind of RBAC model with an account per tenant, although you'll definitely have a little bit more complexity in an object per tenant or a multi-tenant model. And then lastly, our tri-secret secure feature. This is how we handle encryption. So Snowflake as a service, we will handle the encryption and the rotation of keys for you. But at higher levels of editions of Snowflake, you can participate in this process and contribute to the encryption key with your own key. You can think of this as bring your own key. And basically what this means is that if you wanted to immediately remove access to all the data, you could pull your key and that will enable that. Now this is done at the account level. And so this will be more applicable to an account per tenant model. But if your application requires this for regulatory or contractual reasons, this is a feature that you may want to become more familiar with. Okay, so let's move on to optimizing compute and what you need to think about from a scalable data application perspective. So going back to our sort of typical design patterns, what do these pictures look like when we inject compute into the conversation? So in multi-tenant compute or multi-tenant table, you're ultimately pulling users onto common compute. So in this instance, we're pulling orange, purple, and pink onto one compute, teal and blue onto a different compute. And it really doesn't matter whether that compute is going to query a multi-tenant table or a object per tenant model. It really doesn't matter. This is where you can mix and match those things. The idea here, though, is that tenants are going to share compute and you're going to try to gain efficiencies in your compute spend by having them do so. In object per tenant, we're going to start to dedicate compute to different tenants. So you can see here orange and purple have their own dedicated compute. And again, it really doesn't matter whether orange is going to its own object per tenant database or whether purple is querying a multi-tenant table. We can still dedicate them on their own compute. So again, this idea that you can mix and match these models. And you can even create a hybrid model from a compute perspective where some of your tenants, pink, teal, and blue, are on a pooled compute where purple is maybe paying for a higher tier of service, or maybe they have a stricter contract with you that they need to be dedicated from a compute perspective. So you can mix and match these models as you need to, both from a compute perspective and a data storage perspective. And then lastly, account per tenant looks very similar to what we saw before. The difference here is that because compute does not span Snowflake accounts, you're going to have a separate compute within each of those accounts that's dedicated for queries from that tenant. So you can see there, the orange is going to get routed to the orange account. There will be a database in there. There'll be a warehouse, a virtual compute cluster in there for querying that database, and then a separate one for purple and a separate one for pink. Still having the concept, though, that pink could connect directly to that account and use that compute accordingly. So this is the primary difference in our design patterns here, where the sort of compute resides and how you give different users or tenants access to that compute, which we'll talk about more here in a little bit. First, it's important to understand, though, when we talk about compute and building a scalable data application, there's sort of two dimensions of scaling that you need to understand in Snowflake. So I just want to cover them quickly here. So the first is vertical scaling, where you're increasing the virtual warehouse size. And you can see there in the picture, we size virtual warehouses based on t-shirt sizes, going from extra small all the way up. And the more compute you add typically means the faster your query is going to run. Typically, going from extra small to small will double the speed of a query. Small to medium will double it again. However, there will be a certain point where adding more compute gives you diminishing returns, and you're not going to get that sort of linear improvement in speed. And that's usually where you recognize too that you've hit the sweet spot for where you should size your workload, where you're no longer getting that, double the speed performance, because that will optimize your price performance level. And you can configure vertical scaling with both the UI as well as the SQL statement that you see there. What's important to understand about vertical scaling, though, is that it's not automatic. You can resize a warehouse anytime you want, even when it's running and even when it's actively serving queries, but you have to make the choice yourself to resize it. Whereas horizontal scaling is about adding more clusters to a given warehouse and introducing load balancing into that virtual warehouse. And by doing that, we're able to increase the number of users or the number of concurrent queries that we can handle on a given virtual warehouse. And so the way you do that is by defining a minimum cluster amount and a maximum cluster amount, where the minimum is the number of clusters that will always be running, 3 in this case. And the maximum is the amount that you're going to let Snowflake scale out to if concurrency increases. So this is how you can build a really scalable data application, by having the setting like you see there, 3 to 10. So if you're always running 3, and suddenly a lot more users come on the system, we'll spin up the 4th for you. We'll spin up the 5th, the 6th. And when that concurrency goes away, we'll spin them back down until we get down to 3, the base level that you want to constantly run at. And again, this can be configured in the UI, or it can be configured with a SQL statement. So with the vertical and horizontal scaling in mind, let's talk about how we can use that. And so the first is with workload isolation. So in Snowflake, you can define as many compute clusters as you want, and you can just define them at different sizes for different workloads. And they can all be running concurrently on the same data, doing different things for different purposes, sized appropriately for their workload. So in this diagram here, you see we've got an ingestion compute that's got one green box that represents a small or an extra small, if you will. That's running to ingest data regularly into Snowflake. We have another compute that's constantly doing transformations, and some of our transformations are pretty complex. So that's an extra large or a 2XL or 3XL warehouse that's doing all those transformations. And that those transformations will never collide with the ingestion. And then we can designate virtual compute for the tenants as well. And they could be a completely different size based on what you want the performance of those to be. And in this instance, we've actually created 2 virtual warehouses, one where we're going to dedicate to tenant 1, and a different one where we're going to pull tenants 2 through 10 onto that compute. And so how you isolate workloads and how you size those warehouses for those workloads is one of the things that allows you to build a really scalable data application. Now, the beauty in this is, again, that we can isolate those tenants. And by isolating the tenants, we can say that, hey, tenant 1, they're going to get their own dedicated warehouse at whatever size perhaps that they're willing to pay for, or that we're willing to dedicate to them. And whatever they do will not collide with anybody else. Whereas tenants 2 through 10, maybe they're paying at a lower tier, and they recognize that they may not always have as speedy performance in the queries that they're running based on the level of service in the application that they're paying for. Now, one thing that you want to think about when you're sort of deciding how to isolate your tenants or not is the use warehouse command that we'll talk about a little bit later. That's how you can direct certain tenants to certain warehouses. And then you want to also think about what types of things are important to you from managing COGS. So for example, in this scenario, it's going to be really easy to understand the COGS of tenant 1 because they're on their own dedicated compute. Everything that happens on that compute is correlated to tenant 1. Whereas tenants 2 through 10, if you have strict COGS requirements to understand those, you're going to have to develop some pretty strong heuristics to figure out what costs get allocated to 2 versus 3 versus 4, et cetera. So COGS per tenant is easier to track when they're isolated. Pooled tenants also will compete for resources, so think about that. And isolating every tenant can get expensive, so you need to balance those things when you're thinking about how you're going to do that. The beauty of pooling tenants, though, is you have access to this horizontal elasticity. And so this is what we're showing here is we're expanding from 1 cluster to 3 so that we can handle more tenants. And again, as more tenants are active on the system at the same time, more compute clusters will spin up. Whereas if only certain tenants, maybe tenant 2, 7, 12, and 19 are on, well, maybe only one compute cluster needs to be running during that time. So that's the beauty here of pooling, is that you can design the multi-cluster warehouse to be able to expand for you. Now, a couple things to think about, how many you can handle on a multi-cluster warehouse will vary depending on your query complexity and how much concurrency is happening. You might need to think about how you can minimize the effect of bad actors with multi-cluster warehouse so that one person's not sucking up all the resources. Query cache is unique per cluster, which we'll talk about in a second. And some low latency cases may involve you building your own load balancer across discrete warehouses rather than relying on the spin up and spin down time of our multi-cluster warehouse. So just something to think about depending on what your needs are there. Whatever you do, I encourage you to turn on resource monitoring, because this is how you're going to be able to keep track of compute consumption within the warehouses. You can make these in escalating fashion so that you first just get notified to, once you reach a certain threshold, you can have a hard shutdown of the warehouse and no longer serve queries from it. So you can mix and match these however you need to manage credit quotas across your tenants. All right, so let's talk about some of the security considerations for compute. So I mentioned this earlier. We have 2 ways in which you can direct tenants to different compute clusters. The first and primary one is use warehouse. So if I run a use warehouse command before I issue a SQL statement, that guarantees that all remaining SQL statements in that session will use the warehouse that was named in that use warehouse statement. So you can build that into your application to direct tenants to certain warehouses in that manner. You can also set default warehouses for database users. So if you have each tenant connecting to Snowflake through its own database user instead of a service account, you can actually set the default warehouse for that tenant, especially if they're going to their own discrete warehouse, or even if they're sharing on a pooled warehouse. So keep that in mind. Depending on how you're going to connect to Snowflake, you can use the use statement versus the default warehouse. As I mentioned before, the warehouses will cache data. And so it's important to understand whether this affects your sort of contractual or regulatory requirements. Now, while the tenants can't get at each other's cache, that will never happen. It still is all co-located on a common compute. So if I have tenants 2 through 10 using compute, tenant 2 runs a query, some of their data is cached. Tenant 5 runs a query, some of their data is cached. Tenant 9 runs a query, some of their data is cached. All of that will be locally stored on the compute. That may be a problem for some of you. It may not be a problem for others. So, something to think about as you design your application as to whether or not you need to isolate tenants because of compute caching. And then network policies, these can be set at an account level or an individual database user level. And the idea here is that you're going to be able to restrict what IP addresses can access Snowflake. At minimum, you're going to want to put this in place between your application tier and Snowflake, potentially, as a general setup at an account level, but potentially also at a user level, depending on how your users are connecting through, or if you're using generic service level accounts. That's always a good practice to do that. We'll also, think about how you can't really set these network policies on warehouses themselves. But if you use this sort of combination of a Snowflake user going to a specific warehouse, you can effectively create the concept of a warehouse level network policy if you're using discrete Snowflake users to set default warehouses. Okay, so those are some things you need to think about from a security perspective as it relates to compute. So let's now sort of wrap this up and think about, what everything that we learned here. And I want to do this from two angles. First, we're going to walk through two flowcharts for how you can think about some of your decisions as it relates to your storage tenancy and your compute tenancy. And then we'll just kind of summarize the presentation as a whole and get into Q&A. So from a storage perspective, I want to build an app on Snowflake. The first thing that you're going to think about is, are there strong legal isolation rules that you have? Whether that's because of the industry that you're in, maybe that's because of the type of application that you run, maybe it's because of the contracts that you have with your customers. That's one of the things that you're going to first want to think about. Do you have some of those needs or challenges? If you do, well, what are the impacts of those? Do you need to have an encryption key per tenant? Is that something that's important to your application or to your industry or your agreements with your customers? If you do, you're going to have to go down the account per tenant model, because account is the only level at which we can use that tri-secret secure feature, where you would be able to set a different encryption key per tenant. Now, this is not uncommon. This is not common. Most applications don't need this. So I want to be careful that I don't want to sound like I'm recommending this per se, but it is definitely something that we need to sort of cross off and eliminate before we move on. If you don't have that requirement, then we can start to look at, all right, what are the different ways that we can isolate tenants? Is it okay that we're using role-based access control to isolate tenants? If it's not, then we're going to have to go down the account per tenant model, because that means that we're going to use account lines as the way to isolate tenants. But if our RBAC is okay, then we want to think about, is row level security okay? Is that an efficient means to isolate tenants? And if it is, or if it's not, sorry, we're going to go down the object per tenant model, where we'll create databases, schemas, tables, etc., for every tenant. But if it is okay, then we can go down the multi-tenant table path, where we can combine tenants into common objects and use row level security to drive who sees what within the application. Going back to our sort of legal question, if we don't have those legal isolation rules that we need to think about and think through, if that's just sort of a no right out of the gate, then there's sort of two other things that you need to think about. And they are both similar. One is, are you allowing your tenants to bring their own tooling to the application to connect to the data in some way, shape, or form? You may be hosting this through your application UI, whether you've written it yourself or it's commercially embedded. But some of our application customers actually allow their tenants to bring their own tool, and therefore the tenants are getting visibility to connectivity into Snowflake. And if that's the case, then we want you to go down the account per tenant model, because we have some restrictions in Snowflake around how third parties can connect to different types of Snowflake accounts. And we'll need to talk to you more about what are your sort of different options for how you do that. So if that's a requirement within your application, we need to talk about an account per tenant model for you. If it's not, maybe you still want the customer to be able to log into Snowflake, but just use the Snowflake UI, whether it's our Snowsight product or our worksheet product. You want to provide SQL query access to your customers. Again, if that's something that you need to do, we want you to put those customers into more of a proxy account model using account per tenant, and we can kind of walk you through the details behind that. If not, then the last thing you really need to think about are the data structures unique per tenant. And this is, we alluded to this before. If the data structures are unique per tenant, then you're going to have to go down the object per tenant model, because you can't combine all tenants into sort of a single data structure. And if it isn't the case, if customers are sharing a common data model, then it just comes down to, regulatory or contractual considerations aside, what is your preference? Are you more preferential to RBAC, in which case you might use something like OPT, or are you more preferential to row level security, in which case you may use multi-tenant table? So those are the things that you want to think about from a storage perspective, and a flowchart to kind of help you think through it. Now let's do the same thing from a compute perspective. Now there's going to be some overlaps here. There are definitely some similar considerations that you have to think about. And the very first one is, do I have similar legal isolation rules? And are those legal isolation rules sort of driven by data? Do my data storage isolation rules sort of dictate account per tenant anyway? And if that's the case, well, then your compute is going to be account per tenant based as well, because you're going to line up the compute with the corresponding accounts that you're putting each of those individual databases into for your different tenants. And so that's just sort of a natural path that you kind of have to follow, that if you're going the account per tenant model for storage reasons, you have to pretty much follow suit for compute reasons as well. But if you're not, then you will need to think about some other things. Do you have strict network policy requirements that you have to put in place? If you do, you might need to follow the account per tenant model there, or you might need to think about how you design your user access into Snowflake so that you can create those network policies at a user level and maybe do OPT instead, where you're creating different warehouses for different tenants. If you don't have sort of strict requirements there, you might have basic requirements for network policies. Most people are putting on network policies to some degree. It's just a matter of how strict those requirements are. But if you have more basic ones, then we start to get into some other questions. So first of all, is it a big deal that data cached on compute is happening on compute used by multiple tenants? Is that a problem in your application for whatever reason? If it's not, or if that's not allowed, then you definitely want to go down the OPT route, where you're setting a discrete compute for each tenant, so that you can, make sure that that cache is correlated to the specific compute that you designate for each tenant. But if it's not a big deal, and it's okay that even though the tenants can't access that cache, the fact that it's there is not harming anything, then we need to start to ask some other questions. And those are around, how strict are your COGS per tenant? Some of our application customers just have that sort of directional need. Others have more strict needs. So if it's more strict, then you want to go down the object per tenant model, so it's easy to calculate. But if not, then you can start to ask things like, okay, is it okay if tenants collide with each other and decrease performance, even in a multi-cluster warehouse scenario? If it is something that you want to try to prevent, then you might go down the object per tenant model path. If not, then you can look at the multi-tenant path, where you're going to pull users onto common compute. And then, of course, you also want to think about both of the situations where tenants are bringing their own tools, because that still applies as well. The account per tenant models are going to have to be used in those scenarios. And it really doesn't, compute has to follow same way with what we talked about above with storage rules. And then lastly, if none of those things are a factor, you can evaluate all these other parts of the flow chart accordingly. Okay, so let's wrap up here and then we'll get to some questions. So obviously you want to think about how you design Snowflake to ensure the scalability of your multi-tenant application. Think through this. As the number of customers increase, it's important that you have a good tenancy approach in place and that you think through this ahead of time. It is possible to change. Some of our customers have changed styles midstream, but it's better when you can think about this up front and you can have it set the way that you're going to need for your application. We support a range of tenancy options, from full isolation to complete pooling of resources at the data or the storage level, or the compute level. And we kind of refer to those as account per tenant, object per tenant, and multi-tenant tables as the different models that you can adopt. And that allows you a lot of flexibility in how you combine those together, and you can pull things and isolate things based on workload, based on contractual reasons, based on a number of different factors for your application. And security plays a huge role in both of those techniques and approaches. So you're going to want to think about how you're going to make sure everybody's using and seeing all the right things in your system as it relates to your tenancy model.
Okay, and with that, DZone would like to thank Kevin for a great presentation. DZone would also like to thank Snowflake for providing our audience with a great webinar. Lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day.